Okay, this is our group task for problem 5.19 given by Dr. Abdul Rahim. So we look at the questions. A 100 HP 440 V 0.85 pH leading delta connected synchronized motor has an armature resistance of 0.3 ohms and a synchronized reactance of 4.0 ohms. Its efficiency at full load is 96%. So we can look at the question A. What is the input power to the motor at rack conditions? Okay, the efficiency is 96%. We convert it into 0.96, and then in the efficiency for the formula is P out over P in. Okay, then you can write it down. 0.96 equals to 100 HP. Okay, the 746 watt is given by the formula and then divided by P in, so we can get the P in is 77.7 kilowatt. Okay, the next one, we need to find the line current of the motor at rack conditions and the phase current of the motor at rack condition. Okay, the first one, the line current. For the formula that given in the slide, P in divided by square root 3 voltage and the pH, PF. Okay, so substitute the formula 77.7 kilowatt divided by square root of 3, 440. Okay, bracket 0.85 equals to 120 current. Okay, so we will find out the line current is 120 ampere. The next one, the phase currents to the motor at the rack condition is, okay, since this is a delta connected, so you can find the current, the phase current equals to the line current divided by square root of 3. 120 ampere divided by square root of 3, we can find out is 69.3 ampere.
Thank you, Yong. My name is Ryan. I'm going to continue with the presentation with the tutorial at C. Okay, so we are going to talk about the reactive power supplied by the motor to the power system at rated condition. So we will see that we need to find the Q rated, which is the reactive power. Is the Q reactive power over here. Alright, so if we take from the phasor diagram, so it's usually the can see that the reactive power is the Pythagoras theorem. Here is always will be the sine, here will be the cos. Alright, so because of here's the sine, obviously we're using sine instead of cos, so we're using 3 V phase multiplied by I line current, and then after that you multiply by your sine theta. Your theta is take from your power factor, which is 0.85. The degree of getting will be 31.79 degree, and then after that upon mathematical calculation you get 48.19 kilo watt per resistor. It will be that will be your VR. And then nextly we want to require to find the internal generated voltage at the rated condition. So to find the EA, we have to use the V phase minus the RAIA minus the inductance impedance JXS, and then with the IA, so you put all the value inside and you're getting 619 with the angle of negative 23.5 degree. So the stator copper, we need to find the stator copper losses at the rated condition, which is 3 multiplied by IA squared, then after that multiply by your RA. So I square R, because now you need, since it's a 3 phase, so of course you need to multiply by 3 I square R. So you can get your IA through your 69 point your I through your phase side current and your motor 69.3, and then you multiply by your RA, which is 0.3 armature resistance. Okay. is given, right? It's not there. Okay, yeah, your armature resistance is given over here in the question above, and then you can get 4.3 kilowatt. That's your stated copper losses. Alright, I'll pass to my next teammate.
Hi doctor, my name is Kumaran. Now I'll explain for question E. What is the power conversion at rated condition? So before we find the value for power conversion at rated condition, we need to find the copper losses. To find the copper losses, we use this formula. PCU equals to 3IA square times RA. For the IA square, we take from earlier calculation. At the part B, there we can find the value for IA 69.3, and then for the RA we can get from the question here, which is 0.3. So for the PCU we get 4.3 kilowatt, and then for the P converted at rated condition is P conversion equals to P in minus P copper loss. So P in equals to 77.7 kilowatt minus 4.3 kilowatt, and finally we'll get for 73.4 kilowatt. Okay doctor, that's all from us. Thank you.